All right. I guess we could get started here. Weird. For some reason, I'm getting some sort of like button in the live stream. That's fine. We'll worry about that later. Welcome to Common Lisp Study Group. Today we're going to be talking about, continuing our exploration of the Metaobject protocol through reading The Art of the Metaobject Protocol. Specifically, today is going to be on the introspection utilities. Last time when we started talking about it, we started our basic exploration of the Metaobject protocol by looking at the core class meta-objects that have been provided by the protocol. These are things that are representing kind of like the base pieces, the primitives of an object-oriented system, and we specifically used it to start creating some aspects of a basic subset of a class called Closette that's in the book. Of course, we didn't go through some specific examples of that, primarily because I think it's useful for you guys to actually go through Closette yourselves. Instead, I've decided this episode, when we're starting to talk about the introspection utilities, to go and start leveraging a more complete third-party implementation of the MOP that goes through and implements some of the different missing pieces of the MOP that's in different Lisps, called Closer MOP. It was created by Pascal Costanza. I don't remember, I think a long time ago. I first heard about it back in at least 2007, so I mean, it's at least that old. It's a fairly complete implementation of whatever is actually provided in the book, and I thought it would be great to at least leverage that to start going through what's available for you today. Are there any questions on last week's material before we get started? I'm just going to ask both on the chat room as well as the live stream, so that way folks can get an opportunity to ask questions. While that's working, I'm going to try and see why I'm getting this weird extension button. Okay. For some reason, when I'm sharing my screen, it's showing us some weird button. Give me a second. I'm gonna try and get rid of this guy. 1 second.
I have some utility functions for the MOP that might come in useful to discuss and learn how to work.
Sweet.
How to get all the arguments, the init args of a class, or how to get all the accessors and stuff like that.
Oh, great!
They're actually fairly involved.
Yeah, let's go through that. Because I was thinking exactly of level editors when I started reading through chapter 2, to be honest, because there's for game objects, I could totally see some of these functions being available, making it much more convenient to write level editors for video games. So yeah, let's touch base on that. This is really bothering me. I don't see this on my screen, but on the YouTube live stream, there is a incessant Chrome extension dialogue showing up. Sorry, folks. For some reason, this is not showing up on my screen, although it's popping up on the YouTube live stream. I'm not entirely sure what this this dialogue is where this dialogue is actually coming from. So I guess I will. You know what? If it becomes a problem, I'll take care of it in a different way. Hopefully, I can adjust the screen for that. Let me share my screen again. Give me a second. All right. Okay. So to begin with, I thought I would create, kind of like a dummy class, called a point to kind of illustrate some of the introspection utilities.
Oh, Ram, that dialogue on YouTube is coming from Jitsi. That's the same one that I was talking about. So maybe if you switch to your Jitsi screen, you'll be able to click it off or something.
I don't see it here, but that's
I would suggest, so you're the host, right? So if you leave and rejoin, it'll probably kill the stream off, won't it?
Yeah, it will probably kill the screen. That's the reason why I'm trying to see.
Yeah, Jitsi has a bug in that it asks you to install the Chrome extension on Firefox.
No, this is asking for the Google Calendar and Office 365 stuff.
Yeah, it's a Chrome extension though, and he's using Firefox, I would guess.
I am not using Firefox. I'm actually using Chrome. I just updated Chrome.
Okay. Well, that same dialogue shows up on Firefox, oddly enough.
So this is kind of weird. As long as it's not bothering people on the screen and can actually see my code, I don't think it's a big deal. It'll be just sitting there on the stream. Okay. But I'll deal with it accordingly. Thanks a lot, Google, for giving us this very nice extension dialogue.
And I posted the gist in the chat of that pretty hacky code I wrote.
All right. So I will go ahead and copy this into my buffer for discussion, but I have a question already. Primarily, is C2MOP different than CloserMOP, or
nope? Nope.
No, and also whenever you see A:, it's Alexandria, and whenever you see U:, it's Golden Util. It's two different utility libraries that's used for those functions.
Let me go ahead and create a package here. Just so that I can actually use.
Actually, looking at it, there's only one case of U:, and it's for make keyword, which is slightly different than Alexandria's, but you could just swap it out without any functionality loss for Alexandria's. You don't need Golden Utils.
Okay. Let me just make sure. All right. And let's go ahead and compile this guy and this guy. All right. So last time we kind of started going through some of these core APIs that are available to you when you start trying to look at introspection. But before I, try and explain what kind of available in CloserMOP and stuff, I thought I at least want to bring up one just distinction, just for folks who aren't familiar with introspection utilities in general in programming languages, and just have never actually tried to explore reflection in languages like Java, C#, and even Python has a Metaobject protocol. It's very, very similar. If not, I think it's probably the grandfather of a lot of these Metaobjects that are available in those languages. It's a core set of libraries that allows you to. Introspection utilities are basically a core set of APIs and functions that give you a uniform kind of function interface for exploring what's inside of a class declaration, what's inside of methods, what constitutes kind of the methods, like its init arguments, what parameters are available. In a general, you have the ability to also look at, in terms of slots, what the init form is, like what is the actual Lambda function that gets executed when you create instances and so forth. The core of the APIs, I would say, is really the things that will give you access to the class instances and more information about the slots. There are things related to like methods, things that the book doesn't indicate as being part of the introspection utilities, although they are available for other uses. So I thought we'd get started on at least going through the, just what can you actually go and use this for in terms of writing utilities for, say, browsing your classes and even browsing your method implementations. One thing to note, and one topic of discussion that I wanted to kind of bring up before we get started is something that the book calls the fair use rules that the user must respect when leveraging these introspection utilities. And I thought I'd ask some of the more experienced Lispers here on the channel, kind of give their thoughts on this. But there are three specific assumptions that the book mentions when leveraging this API that the user must respect. One is when writing utilities leveraging these API functions, and this is not only for the class declarations, but also for the methods and generic functions and so forth, you should not assume any sort of return ordering from any of the functions. Like one example here is I've written to kind of illustrate this is when you're trying to access the slots that are directly associated with a particular class object. So here, if you look at this piece of code here, we're just simply trying to access the direct slots in the class declaration for point. And as you can see, when I execute this function, it actually returns the slot definition objects themselves, X and Y, but the ordering of those are not guaranteed. They are, so basically, if I'm understanding this correctly, it means that they're equal but not EQ. They'll have the same contents, but they may not exactly be the same.
No, that's not the case at all. Because equal still respects ordering. Really, what it would be is that their set difference is nil.
Okay.
Or their intersection. Their intersection is nil.
Rob,
No, their intersection is. Oh yeah.
I rejoined because I didn't like your screen. Your sharing screen froze, and when I rejoined, it says you're not sharing your screen at all. So I don't know if there's an issue on your end or if it's just.
It's not on his end. Well, it sort of is. It's your Jitsi client doesn't think it has enough bandwidth to stream his screen, but it'll reset that if he restarts his screen sharing.
Okay, I could do that. Give me a second.
Yeah, I've encountered that many times.
Yeah, me too.
Can you see it now?
I do
It
not.
should reset. Well, that's irritating. It's still getting to the live stream.
Yeah, I can see it in the live stream.
Oh, he left. And he's back again.
Give me just 1 second. I need to send myself.
Okay.
Someone on.
You're muted.
Am I muted?
Mm-mm. Michael is. Oh, and he left again.
Okay. So give me a second.
He's actually on twice, and one of his connections is.
So
Seems a lot of people are leaving and rejoining.
Yeah, Jitsi is giving us some technical trouble.
Yeah, it seems to do that.
Let me go ahead and post this.
Michael, you're actually on the stream twice, according to you're on the in the call twice. So I can tell.
Hopefully that gets.
And you're unmuted, but I can't actually hear you if you're talking.
Oh no, I had so someone on the chat and the YouTube live chat said they wanted the gist.
Oh,
of the,
I actually already linked that.
Oh, you did. Oh,
Yes,
I didn't.
that was my comment right above yours.
Oh. All right.
Yeah, beat you to that one.
Okay, all good now.
Okay.
All right. Cool. Let's let's continue. So you basically you said that set difference is nil, but it's not that they're equal or EQ. So that was the
Correct.
second thing that they were talking about. I was mixing the two up. So the set difference is nil, but there was also one related to EQ or equal, which was the second thing, which is users should not make any assumptions about results obtained by retrieval or recomputation. So that basically means that you can never assume that we've cached results of a particular query, but you can guarantee that the results are always going to be the same upon for successful calls.
Correct.
Okay. And then this one is really odd too, but I don't know about either, which is about changing the state of the meta object. So does that mean that the meta classes themselves are they're not like they're not, since they're not user defined classes, they're lower level classes. There's no way of using things like what's the word, redefine class for initialized instance and
so really basically is that once there's an instance of a meta class, it's not well defined whether or not you can redefine that meta class portably. Okay. Anyway, well, if you define a meta class, you shouldn't ever redefine it. It's not SBCL. I'm pretty sure will handle it more or less reasonably, but it's not portable redefining meta classes.
Okay. Okay, so these three are really important then that we must respect.
Something's gone off on Michael's end.
Yes, if there's a fire.
Yeah.
Sorry.
Is there?
Hopefully he'll be fine.
All right, I'm not burning. We're good.
Good.
All right, great, fantastic. Okay, just making sure.
So Ram, on top of those three criteria that he had, he also at one point said something about, like, you know, they're very well defined data structures. I don't know, that seems like a bit of a stretch to me, since everything just seems to be, like, you know, lumped together with like random lists that you're basically you know, you're setting slot values to these lists that you're supplying, and then you're just basically retrieving the same thing later. So
right.
I don't...
That's a very important. That's a very interesting point, Michael. Yeah, it's at least the implementation that he gave. Like, there's all lists all the time that are being created. So
there's no guarantee that an actual implementation would use lists for the internal stuff.
Okay. So just because he has it in his basic implementation, his reference implementation, if you will, doesn't mean that we should be assuming that all implementations has followed the same approach. Okay.
Not for the internals, no.
Yeah, and that makes sense, right? Because, you know.
Those are internals.
Yeah. But it's very, very interesting about the three rules that he made, because the recomputation one was really odd for me, because like once a class is instantiated, our class meta class has been defined, like I wouldn't have considered that some implementations would have would think of having the differences between a computed data structure on the fly versus caching it, because once something has been defined, you'd probably want to cache the results anyway upon first declaration. But I guess that's an assumption, not necessarily a hard fast rule.
Not caching it could make redefinition easier if that implementation wants to support redefinition of meta objects.
Right. That's a very good point. So before we,
at the expense of performance, of course.
Yeah, of course. So there are plenty of these class API calls. I'm not going to go through all of them in detail here, but a couple of ones that I thought it was pretty neat were on top of class direct slots, which is what I'm illustrating right here. There's also things called class direct methods, class direct subclasses, and so forth. These are all essentially querying that class meta object that we kind of talked about in the last stream. I could later on bring up an example for folks just to show them how one might implement such a class. But it will include all these: the direct slots, the precedence list, the class slots, and so forth. It's basically accessing the structure that was created by the make instance, which for folks who have been reading the implementation in the book, the way they implemented make instance right now is using a def struct for some of the baser meta objects. So, Michael, could you walk us through these two functions that you nicely?
Yeah, sure. If I could remember how they work, yes. Give me just a second.
Okay.
Let me pull it up on my end here.
And I
can't see your screen again, so.
Well, Michael is set up. I just want to also mention that there are very nice convenient APIs for things for accessing slots too as well in this core Metaobject protocol. One of which is that I'm just going to show is like slot definition init args, which I think I could do is init arg2 is associated with the slot. So to access this guy, how do I access a specific slot? I guess I could do slot value.
No, you need to do you need to either call class slots or class direct slots on a class object, and that'll get you a list of the slots that are defined by that class.
Okay, so let's do this. ELT
C2 mop.
mop.
C2 mop.
Oh, C2.
No one types closer mop all the way out anymore.
All right, C2 mop is okay. I didn't realize that's what. Okay, that makes sense.
It's just an alias. It's another nickname. It's a global nickname, so don't really like that, but oh well.
Last point, and let's say the first access. Very nice.
Mm-hmm.
That's pretty cool. All right. So
Yep.
using existing utilities to actually be able to access that. Those are
You can also use just plain class slots if inheritance has been finalized, and that'll include the slots of parent classes. Direct slots is only the slots that are defined by that one class.
Okay, let's see this. All right. I'm going to go ahead and put both of these examples here. So this is accessing slots in the direct class itself, excluding superclasses. And predecessors. Okay, cool.
Class does have to be finalized before you can call class slots, though. Otherwise, it'll error.
Yeah, and that's what the first part of the let that let
Yep.
does there.
Yeah, give me 1 second. I accidentally closed my buffer here. Okay, there we go. All right, whenever you're ready.
Well, I don't remember too much about this, but basically what's going on is, well, the first thing we do in that let statement there, or let expression, is ensure that the class is finalized. This is important because, well, it needs to be finalized. It needs to be. There's no way around that. You can't use most of the MOP unless the class is finalized.
Are we all familiar with what it means for a class to get finalized?
I know that def class requires it, but I don't know what
So def class finalizes a class.
Right.
It can. Well, no. Def class doesn't necessarily finalize
No,
a
it
class.
doesn't.
That's right. Yeah. So there are a couple things, right? The first is that you can forward reference classes in the MOP. You can have a class where one of the superclasses hasn't been defined yet. You can't forward reference classes in as a specializer for a method. If you reference a class as a method specializer, it'll error. But you can forward reference superclasses, and so that means is that that your class gets defined, but it can't completely define your class because it doesn't know the information about the superclasses yet. And similarly, it also has to track that you forward referenced one of those superclasses so that, when that superclass does get defined, it knows what classes subclassed from it and it can update them accordingly. And so the effect of all of this is that a lot of metadata about classes isn't actually computed usually until the first time you instantiate the class, because it just that's in a lot of implementations anyway.
Right, and
They delay all the way until
instantiating a class does an implicit finalization. So
yep, it
that's one way
forces
to finalize a class if you don't want to call in
Yep.
finalized.
But basically, a lot of metadata about classes just isn't accessible until you finalize it, and so the MOP provides a function that ensures that a class has gone through finalization before you try and access that metadata.
Interesting. Yeah, so I know that there's a function that we talked about last time called finalize class, but I assumed that it was in ensure class or in one of the other lower level functions that were used by make instance or def class.
Yeah, make instance, sure. Def class doesn't. Def class, ensure class does not finalize a class.
Okay.
It can't.
I may have misread that.
Because when you use def class, you can forward reference a superclass, and now your class can't be finalized yet. So def class can't finalize.
Okay. That makes more sense now. Okay, so because we have forward references, it has to happen at make instance time. It can never really be...
Well, it could happen as soon as all of the superclasses actually get defined, but it can't happen right away.
Okay.
And most implementations do delay until you try instantiating the class for the first time.
Gotcha. Okay. All right. That makes sense. Interesting. I'm just double checking to make sure I didn't misread this here. Yeah, Yeah, it was an initialized instance because it does a finalized inheritance. It has the last operation before actually returning the class instance itself.
Mhm.
Okay, cool. All right. All right. So it has to finalize the actual class before it can actually. Okay. So this will allow then the next method to be able to compute all the slots once the class is finalized.
As a side note, I'm pretty sure, Michael, you could have used C2MOP class slots there instead of writing your own recursive function.
No, I couldn't because the functions such as slot definition writers and slot, they require an effective slot definition rather than a slot definition. There is a difference.
Yeah, I remember that, but I wasn't aware that class slots returns. I could have sworn that class slots returns an effective slot definition meta object. I could be wrong though.
I think you might be wrong unless I messed up, but I was like scratching my head over that to begin with.
Can you?
Yeah, basically, get all direct slots. It's a recursive function that is basically, walking the precedence list to generate a list of all the direct slots of each superclass, including the class itself.
So then, what's the difference between that and is class slots including?
Well, let's try to call this function on something, and then we can replace it with what Elijah just suggested, and see if we can run into the difficulty that I was facing when I wrote this.
Okay. So let me compile these guys. Ooh, what?
Oh yeah, replace the U with an A.
Oh, got it.
That would be a good exercise if there is a better way to do this. I'd be interested.
All right.
I'm reading this, and actually, it looks like direct superclasses returns regular slot definitions, and class slots returns effective slot definitions.
And I think there's a distinction there that needs to
Oh
be
yeah, no, there is a distinction there. It's just interesting.
Let me go ahead and make this into a 2D point, and then I can make a 3D point subclass, a 2D point, just for stupidity's sake.
Yeah, there's two classes. Yep. Should be good.
And then I'll add a Z coordinate here. Z. Okay. What? Oh, I typed it wrong. Sorry. Accessor. There we go. All right. So now let's compute class accessors on
3D point.
3D point. But I have to quote it, right?
Yes.
Okay.
Need to give the class name.
Oh. Should I just do find class then on this?
No. It takes
No, that's
the name.
good. Just quote it.
Okay.
It calls find class for you.
Oh, I may have. Hold on.
Recompile those?
No, it's because I said accessor instead of accessors.
Oh, yeah, that'd do it.
Okay. Wait. Why are they keywords?
Because didn't you say that this is keywords on this one?
Oh, you named your accessor a keyword. That's kind of wrong.
Oh, yeah, you did. Don't do
Oops.
that.
Sorry. That's right.
Yeah, easy mistake.
I mean,
to
it'll
make.
work, but yeah, you don't want to do that.
It's not a good idea in general.
Yeah. Sorry.
Yeah, and recompile both of those. Yeah,
All right.
there we go. Yeah, now could you go up to the compute class accessors and replace the call to get all direct slots with C2 mop : class slots? Not in there. Not in there. 'Cause that
no,
is
down
in the
one-
definition.
in the left.
Yeah,
Yeah,
there.
right? So
Yeah.
do C2 map.
Class dash slots.
Right? Okay. And recompile.
Yeah, try that.
Slot definition.
Okay, so
Yeah,
that,
slot definition readers needs an effective slot definition.
no, but that is an effective slot definition. It needs a regular slot definition.
Oh, yes.
It
That.
needs a direct slot definition, not an effective
Yes.
slot definition.
Okay,
Yes.
so what is the exact difference between a slot definition instance and a standard effective slot definition?
So there's direct slot definition meta objects and there's effective slot definition meta objects, and the difference has to do with a direct slot definition is one that's actually defined on that one class, whereas
Yeah.
an effective slot definition is includes slots that are inherited. And
Okay.
it's effective slot definitions are what you get after doing compute slots, which happens after doing finalize inheritance.
Okay. So
Which
effective
computes the
slot
full set of slots.
definitions are essentially the entire inheritance hierarchy slot applied to the class declaration itself.
Yep.
Okay.
Yeah, and it's important to realize that happens after you finalize a class.
And not only
I just find it interesting that
But-
the readers aren't available on the. I guess that sort of makes sense. It's just weird.
And that's why I have that recursive.
Yeah, I see.
I don't
see
think
what
there's
you
any
mean.
way around that.
I agree. I don't think there is. That's interesting. I think you're not usually supposed to be introspecting that specific thing in that way, but it works.
But I haven't found another way. If you know of a better way,
I don't
please
think
do let me know.
I don't think that there is a better way. I don't think you're supposed to be introspecting the full list of readers defined on classes quite like that.
Which is kind of odd because, I mean, you probably want all the accessors, not just the one specific to that class.
Sure. But also, I think that semantically talking about it like that doesn't make as much sense from the perspective of the MOP.
Fair enough.
Because the way that the reader is defined is that it's a method that gets defined on that one class. It doesn't get defined on the subclasses.
But in certain use cases, you would want to not know the superclasses when you're trying to
Right. Yeah. Here's the other reason. Right. Yeah. The other actual reason, yes, is that you can define a subclass which has a different slot name, but which overrides an accessor from a parent class.
Right.
Yep.
Nothing stops you from doing that, which would actually cause that accessor to show up twice in your get all direct slots stuff. But you remove duplicates, so actually, who knows which one you get?
If we scroll down a little bit, I completely forgot what that whole nonsense with the packages and removing duplicates is doing there. I'm trying to understand it right now. I forgot why I did that.
So you did remove duplicates, remove if. The symbol is in there. Doesn't exist. And it isn't. It's not defined as an external symbol.
Yeah, so that means that you're only getting accessors that are defined using symbols external to their package or symbols which aren't in the current package.
Okay.
If I'm right, if I'm reading that correctly, you're only
Okay.
you're removing symbols that are not either in the current package or exported from the package they're in.
Okay, so we can ignore that part. You could probably remove that with no loss of functionality.
But then you have that
duplicates though.
Yeah, but that remove duplicates does weirdness, in my opinion. Because you don't know which one you'll get, is my point.
That is true. Okay.
But I don't know if there's a way around that, because all that tells you is that a method is defined on that generic function, and no matter what, you're always going to, when you end up calling that generic function, get the most specific method. So, yeah, who knows? Doesn't really matter, I don't think.
I told you this was quite a bit hacky.
Yeah, I can tell. It is quite a bit hacky.
So at the bottom there, we're mapping over all the slots that we found previously, and we are basically appending all the slot readers and writers, the symbols representing those readers and writers to a list. And we're using Alexandria's map append here. For the reason being that if you were to use something like mapcan, which does the same thing but mutably, you'd be overwriting an implementation defined list. And you'd basically corrupt your image and you'd have to restart it.
Oh, okay. All right. Fantastic. At least you fit.
Yep, mapcan is a destructive operation.
I've never had considered that being a destructive operation.
Yeah, mapcan and mapcon are both destructive. You probably don't want to use them unless you own the list and you don't care that it's being modified.
If mapcan's equivalent is mapappend, then what is the mapcon equivalent in Alexandria? Do you know?
I don't think there is one.
Okay. Yeah.
But yeah, that's all that's doing. You can ignore the middle there with the remove duplicates. That's probably a bad idea. But other than that, that's pretty simple.
Yeah, but even in this remove duplicates case, is it removing the, especially if you're able to change the accessor name, you're not necessarily removing an accessor that's technically pointing to the same slot, are you? Like this only removes real duplicates, right?
Yeah, that's what it's doing. It's there's no like determinism involved, but it's trying to make it so that if multiple accessors exist for the same slot, it's only keeping one of them.
Okay.
But yeah, that's specific to
That
my
won't
use case.
actually do
and
that.
It's not really used. It isn't. Okay.
That
What
won't
does it do?
actually do that though. No, what that'll do is if you have two slots that both define the same accessor, it's going to keep that accessor from showing up in the list twice.
Right. Okay. But there's
Which
no
can happen if you have
at all.
correct. But it doesn't matter if because only one of the methods would be applicable to a given class anyway.
Right. Okay.
All that's doing is that like if you have a subclass that defines a new slot and says actually I want this accessor to refer to my slot instead of my parent's slot, the way that you have this defined, what that'll do is it'll cause that accessor to show up twice in the list, even though in either case it would always refer to the child class's slot, because that's how inheritance works. And so you're just removing the duplicate.
Right.
Interesting.
I forgot why I wanted that, but there's probably a better way to do it.
So compute class arguments.
That should really be compute class init args,
Okay, I'm renaming it right now.
because that's what it's doing.
Okay.
This is another hacky one in that we're not doing a full lambda list parsing here. But anyway, so yeah, we ensure the class is finalized again because we need to. So class args.
Oh, that's terrible. I see what you're doing, and that's all kinds of awful.
All right. I'm gonna have Elijah take over because he has better ideas, and I clearly didn't know what I was doing when I wrote this.
Oh,
So-
I can't think of
got
a
it.
better way to do it. I'm not claiming that.
No, really, I do not think I'm pretty good at explaining this, or that I wrote a good implementation. at all.
Okay, so you
So
are
somebody else.
grabbing the init arguments perfectly on all the slots.
So
Um,
grabs all the init args from all the slots,
and
And
then
also grabbing the first method that comes out of compute applicable methods using classes on reinitialize instance for this class.
Yeah, and this is because reinitialize instance also defines init args, not just def class, but you can define new ones with reinitialize instance.
You can also define new ones with initialize instance and shared initialize.
Yep.
oh, so this is not complete either because you'd want to also get because you
You'd
have
probably also want to get ones. You'd actually not even want to just look at the first method out of compute applicable methods using classes, I think, but I could be wrong there. I think you might actually want to be doing something like compute effective method but I don't know what that returns exactly. The effective method is a form that describes how the methods are combined. Inside of effective method forms are call method forms.
Well, we can try it on that class you made.
Yeah.
And play around with it with the suggestions Elijah and other people are making.
Okay, so let's see. What does compute class init args or do to our 3D point? Okay, so these
Well,
are the
all of your init args are defined by the slot init args.
Write a method specialize or reinitialize instance method.
reinitialize instance.
Specializing on 3D point.
This is an after method, right? So
No, it just reinitialize instance. Yep.
okay, instance 3D
Though
point.
you probably would still want to call shared initialize, wouldn't you? I don't know.
I think reinitialize instance calls. No, it doesn't.
The primary method does, but you're overriding the primary method right now.
You're overriding the primary method, which means you'd have to call initialize instance and shared initialize before this, right?
No. You could just call. 1 second.
Oh yeah, you want to do an after method. I don't know. What
Yeah,
else.
because the primary method, the system supplied primary method for reinitialize instance, checks the validity of init args and signals an error if an init arg is supplied that is not declared as valid. The method then calls the generic function shared initialize.
Yep, you want an after method. Sorry about that. Oh, are you? Yeah, I think your screen froze again. Oh, there it
No,
goes.
I got it. So we have a couple of newcomers to our group, and I'm just saying.
Yeah, we got a full crowd on Jitsi here.
Yeah.
Anybody, while we're working on this, if you have questions, feel free to hop in and ask away, because we'll just keep going through here and give you a fire hose of information. So,
so yeah, you want. Yep.
and then
and key.
oh, do I do rest or at key?
Well, you could do either, but in this case, you want to define new keywords.
Okay, so let's say, I don't know, provide alpha value, I guess, and a label. We want to label the damn point. Okay, and now what do I do? So I would have to go and do reinitialize instance. I would have to.
You could just declare ignore them. You don't really have to do anything with them at all.
Label. Okay.
Yep, and compile that.
All right.
And now try running that again. And they are there. Now Elijah made a suggestion earlier.
And that was, you'd have to actually, I would think that you'd want to also include initialize instance and shared initialize instance on here too as well.
It depends on exactly why you're trying to get the init args, because init args are valid in different cases. I'm actually reading the chapter of the spec on when init args are valid.
Okay, well, Elijah, you know my use case. This is for that mix-in system and the prefabs in my game engine.
Right, and so you're doing like change class stuff, right?
Yeah, basically.
And then you're reinitializing the instance after you change the class, right? Or something along those lines.
Something along those lines, yeah.
Cool.
This is probably fine. But yeah, so the spec says that there are two means for declaring initialization arguments valid. Option 1 is initialization arguments that fill the slots are declared as valid by the init arg slot option to def class. The init arg slot option is inherited from superclasses. Thus, a set of valid initialization arguments that fill slots for a class is the union of those defined by the superclasses, etc. And the other one is initialization arguments that supply arguments to methods are declared as valid by defining those methods. The keyword names of each keyword parameter specified in the method's lambda list becomes an initialization argument for all classes for which the method is applicable. The presence of allow other keys in the lambda list of an applicable method disables validity checking of initialization arguments. Thus, method inheritance controls the set of valid initialization arguments that supply arguments to methods. The generic functions for which method definitions serve to declare initialization arguments valid are as follows. Making an instance of a class. Allocate instance, initialize instance, and shared initialize. Initialization arguments are declared as valid by these methods. Initialization arguments declared as valid by these methods are valid when making an instance of a class. Reinitializing an instance. Reinitialize instance and shared initialize. Initialization arguments declared as valid by these methods are valid when reinitializing an instance. Updating an instance to conform to a redefined class. Update instance for redefined class and shared initialize. Initialization arguments declared as valid by these methods are valid when updating an instance to conform to a redefined class. Updating an instance to conform to the definition of a different class. Update instance for different class and shared initialize. Initialization arguments declared as valid by these methods are valid when updating an instance to conform to the definition of a different class. The set of valid initialization arguments for a class is a set of valid initialization arguments that either fill slots or supply arguments to methods, along with the predefined initialization argument allow other keys. The default value for allow other keys is nil. The validity checking of initialization arguments is disabled if the value of the initialization argument allow other keys is true.
So
That's a lot.
That's
isn't
a mouthful.
Oh yeah.
So
Yeah.
If I understood
So
the entire thing.
the short answer is that computing the class init args, it doesn't actually make sense semantically unless you know why you're computing the class init args.
Yeah.
Because it depends on what purpose you're using it for. Because the set of allowed initialization arguments is dependent on the operation you're doing. Shared initialize declares things to be valid for all four cases of so there are four cases for doing class initialization, right? Making a new instance, reinitializing an instance, updating for redefined class, and changing the class, updating for a different class, right? And basically adding methods on the corresponding generic functions for each of those cases declares the new key arguments of those methods as initialization arguments for that method. Just the act of adding a method to those generic functions declares the extra init args. Declaring a method that adds key args declares extra init args. And shared initialize is used by all four of them. And so if you declare something in shared initialize, it becomes an initialization argument for all four cases. But the other ones have methods. There are methods that are specific to each case. And so if you declare a method on only one of those generic functions, it's only going to be a valid init arg in that one case. And so asking for the class init args in general, the only way that would make sense for me semantically is if you're asking for the generic functions that are the init args that are legal in all four cases, and so that would actually be asking for methods on shared initialize. But Michael's specific use case involves calling reinitialize instance on stuff, so I can see why his would specifically be doing that.
Yeah, it's very hacky and specific to my use case, as you can see by the call to make keyword there.
Yeah.
What would happen if you got rid of that? Actually, would the results still be no, it wouldn't, because you're parsing the lambda list there.
Right.
Oh, I see why it's doing that now. So yeah, there's
that's not
there's
even
not
like
an easy way even to get the actual init args from the class.
and that's not even accounting for the fact that there are all kinds of other syntax in lambda lists for
exactly,
how
which
init
is why I
args
said
work.
it's not a full parsing there.
You've tried to write one of those before. I remember how much pain that
Oh
caused you.
wow, yeah, yeah, that's not a fun time. Let me tell you guys.
Yeah.
Interesting. Compute applicable methods using classes.
Mhm. So what that does is you give it a generic function and a list of the classes of the specializers, or a list of the classes of the arguments you would later call that generic function on, and it gives you back a list of the methods that would be applicable to those classes. To instances.
So this is actually looking through the dispatching mechanism to figure out. Oh, that's nice. Oh, that's really nice.
It's getting the most specific primary method, I think.
Yeah. Well, in this case, I think it's getting the most specific primary method, but
I think. But also remember, the ordering of those functions isn't really well defined. So
great, fantastic.
The idea of just grabbing the first one bugs me.
Yeah, this doesn't actually get the fair. I don't think.
But yeah, so compute applicable methods using classes. It actually can return false as its second arg sometimes, and that means that it's actually not possible to compute the set of applicable methods only using knowledge about what classes are being called or are being used, the classes of the arguments. Which can be the case when there are EQL specializers involved, basically.
So let me ask you a question.
Mhm.
You said that this would be semantically acceptable if it covered all four bases. Currently, it covers two. If we were to cover all four of them,
no. It only covers so. No. You need four separate functions if you actually want to do this properly. Because semantically, if you ask for the set of init args that are valid during creating a new object, some of those init args might not be valid during reinitialization, or might not be valid during computing an instance for change classing, right? And so you actually need four separate methods. What you can do is compute the init args that are guaranteed to be valid in all four cases. That you can do. But that's going to be a subset of the init args that would be valid in each individual case.
Okay. My real question is, how do we fix this such that we don't have to do that hacky parsing of the lambda list and making keywords?
I don't know if there
how would we
is
get the
a way.
actual init arg as it's defined in the class?
I don't know if there actually is a way. Because I don't know if that's exposed by the MOP anywhere.
Okay.
I don't know if it's actually possible to introspect.
I don't really know the MOP all too well, and I sort of I was winging it when I wrote this because I didn't know the better way. So I'm sure there's a better way to do it. I just don't know it.
So yeah. So you can come up with you can come up with the default init args defined on the class, but that's not going to respect when methods are defined. It's all kinds of troublesome. I don't know if there is actually a way of getting access to the valid set of init args, if only because that's something that can be changed later without redefining the class. And because you can add more methods. And so I'm actually currently skimming through the spec. So you can.
Couldn't you couldn't you put a layer above the the MOP functions, so when you call them, you can save that additional stuff off somewhere, and then you would be able to access it outside of the MOP.
So you well, what do you mean by save the additional stuff?
I mean, define initialization methods that end up calling the mop initialization stuff. But when you pass in the inargs, you can save off the inargs in like in like a hash.
You would have to make your own def method, basically. And you could certainly do that. You could make your own def method that when it defines extra key args on a given for one of the initialization generic functions, it saves off those key args somewhere, sure. But then you'd only be able to capture the ones that are defined using your alternate def method macro.
And that's actually alluding to, I think, what happens in the next chapter when we start talking about extending the facilities that we currently have here. So yeah, it is possible to do what you're suggesting, but I don't think that requires us to go and re-implement certain aspects of the core machinery for method declaration.
So part of the trouble is that you can't. Actually, can you do something for me?
Yeah, sure.
So I'm just trying to look up the right way to do this because I haven't done it myself in quite some time. Can you call in the REPL compute applicable methods using C2MOP, compute applicable methods using classes, reinitialize instance.
Applicable methods.
Yeah.
Using classes. Okay. Reinitialize instance.
Yeah, and then in a list, pass in find class point y.
Find class point y.
Sorry, 3D point.
Oh,
sorry.
Okay.
Yeah, enter. Right, so that gets us, so there are two methods. There's the method that you defined and the one that's part of the internals of SBCL. Now, do 1 second. It's been a little while since I've done this, so I have to keep citing the MOP for stuff. Generic function, Metaobject readers, call C2MOP.
Generic, I'm assuming.
Generic function method combination of reinitialize instance. Yep. Okay. And now do C2MOP compute effective method. The first arg is going to be the reinitialize instance generic function. Actually, is that the name? Compute effective method. Reinitialize instance. The second arg is going to be star.
Okay.
The third arg will be star star.
Yeah.
Enter. What does that get us back? It gets us back a random expression. Okay. Ha. Fair enough. I had to check.
It is a random express. It's not totally random. I mean, the order in which it's calling the methods are still the order in which I'm expecting it to. Specifically, it's calling
sure
the method before the object.
Yes.
Although, what is this call method list? I guess
internals of.
Okay.
That's internals of stuff. No, my concern is right. Call method is supposed to be. I always forget that like how this is actually all supposed to work. So compute discriminating function, it generates the discriminating function. Yeah, sure. Determine the community. Yes, I can memorize it as follows. Generic function. Yeah, sure. I read this like a good year or two ago, and at the time I had it all fresh in my brain, and I haven't read through it in a long time.
Uh,
I used to know exactly how generic function effective methods got generated, because it's this complicated bit of trickery that goes on to ensure that that everything works out in the end. Because what that expression is right there is going to be the body of a lambda, effectively.
Mhm.
That expression that just got returned is going to be the body of a lambda, which SBCL normally would then compile and store in the discriminating function of this generic function for future times when this generic function got called with that exact set of classes. Does that make sense?
Okay, now that brings up a very interesting question for me, at least, which is for a standard method combination. And I'm assuming, does the affected method get computed at instance initialization time or at class declaration time? Like when
What do
you
you mean?
so like when you define the methods specializers and you're essentially declaring your call chain and your
So when you're defining methods.
yeah, when you're defining methods.
Okay.
When will the before primary and after method combination get computed into an effective
The
method?
first time on SBCL, the first time that generic function gets called with a given set of objects.
Okay. And is there any way to pre?
Nope,
Okay.
not on SBCL. There are implementations where it is feasible to do that, but not on SBCL.
Okay.
Yep, that's true.
So SBCL will, the first time you call a generic function, it's going to work out the set of applicable methods given the classes of the arguments, the positional arguments, if it can. Compute applicable methods using classes will sometimes return nil, and what that as its second return value, and the first return value is who knows what. And the effect of that is to indicate that there are additional methods that might be valid, but it's impossible to know without the actual arguments. And that's basically to prevent it from memoizing away this for the case where there are EQL methods, basically. Because EQL methods can't be detected by compute applicable methods using classes because it needs the actual object to know what methods are valid. There's another function which is compute applicable methods, and it takes the actual objects as well. But compute applicable methods using classes, it gives you back specifically for the case where all you need to worry about is the classes of the arguments, and that means that you can be a bit better in your discriminating function. And so the discriminating function decides which effective method to call based on the arguments. And so the way it works is the discriminating method, discriminating function takes the arguments. It tries to see if it already has an effective method computed for this given set of arguments that would be applicable to this given set of arguments. And if it doesn't, it then invokes compute applicable methods using classes on the classes of those arguments. And if that fails, it goes all the way over to compute applicable method. And that will definitely succeed. But either way, it'll get a set of applicable methods. It will then do compute effective method given the method combination and this set of applicable methods. And that will actually do the method combination bit. Compute effective method is what actually works out the method combination.
But the compilation doesn't occur until the first time the generic method gets invoked.
Correct.
But the return type, what's ultimately executed is a discriminating method. It's not an actual standard method object. It's
correct. So the discriminating function
okay.
is just a function. It's the discriminating function. So do you know, you remember set funcallable instance function?
Yes.
That's the discriminating function is the thing that's set as the funcallable instance function of a generic function. It's
Okay.
what's actually getting called. And the discriminating function, there are protocols in the spec for basically updating that whenever a method gets added to the generic function. And also updating that when it'll implicitly get updated on a lot of implementations whenever you call the generic function and it realizes it needs to compile a new effective method. Because the discriminating function wants to have a nice, efficient dispatch table for the methods that it already has recorded, the effective methods it already has recorded.
Right. And
So-
that's what essentially I was trying to ask about, because I'm wondering where the dispatch table gets generated. Primarily because it's related to another introspection function that was mentioned in the book that I was surprised it was available as part of the API, just because I thought this wasn't available. And that is being able to introspect method environments for a particular method. Like you have now the there's a function in the MOP that allows you to grab the actual lexical environment that's enclosed in the method definition. And I was wondering, well, how would that work with
Sorry, can you say that again?
you can actually grab so there's a function called method environment that returns the lexical environment that encloses the definition for the method meta object. And I was wondering how that would work with say method combination, because I thought environments themselves were not available.
I'm not aware of a method
that's
that
not
does that.
that's not more part of the MOP. It was implementation detail in the book. They
Of
said
class set, probably.
they said there's some kind of implementation function that does something like that.
Oh, really?
Yeah,
So that's
probably
not
has to
actually
be.
part of the mop. Okay, good. Okay,
Yeah.
so now that's the reason why I was like, wait a second, this doesn't look like it's part of the.
Yeah, that probably does have to exist on every actual implementation, but you wouldn't want it exposed that way because the details of it are very implementation specific.
So there still isn't a standard environment API. Okay, good. That's
Nope.
all I really need to. That's ultimately what I was asking, because I was like, wait a second, we've had this
That's part of CLTL2, really.
Okay.
Yeah, in any of
A
it, yeah.
semi-portable way.
Yeah, and yeah, as much as it is.
Okay. All right. Cool. That
But yeah, so
that
yeah,
clears
so-
that doubt. 'Cause I was looking at it and I was like, what the hell? Wait a second. When did this come into the play? I thought there wasn't. So I thought I'd ask about it. Okay. Cool. Yeah. This
yeah,
bit, so we've been talking about quite a bit here on the introspection utilities. Since there's a full audience here, any questions from folks that are online? BL, having some difficulty seeing Bugram screen. Okay. Any other folks that are having trouble seeing my screen?
No, I can see it fine.
yeah, I'm not having any issues over here.
BL,
You're suddenly a lot more quiet, though.
my
There you are.
suggestion is probably to exit and rejoin the Jitsi chat and see if that helps. I know we've been having some technical difficulties with Jitsi. If that still doesn't solve the problem in future broadcasts, we'll see what we can do to fix some of these issues.
Thank you.
No problem. we have a newcomer, Bad Karma, that was asking about just common Lisp books and suggestions for reading. We're currently covering The Art of the Metaobject Protocol, but some of the suggestions that you wrote, Common Lisp, A Gentle Introduction to Symbolic Computation, is actually a very good introductory book.
Yeah, I would say it's an introductory book to programming in general. If you already know programming in general, I would skip right to Practical Common Lisp because the other one can go kind of slow.
On Lisp and even Anti-Common Lisp by Paul Graham are really good books that goes through the language in a pretty decent detail. On Lisp in particular, for folks who are into who are trying to look at how one would do bottom-up programming and functional programming in general, has some really great chapters on that, and as well as, cannot stress this enough, it has a fairly decent macro tutorial in addition to the stuff that we covered in our macro tutorial series. As part of covering let over lambda, which is kind of considered the successor to on Lisp. On top of that, AMOP and some other books on Common Lisp, like Common Lisp Recipes, that goes through some of the practical issues. I would suggest to go through those two as well, because those are really nice.
Maybe last, go through them.
Yes.
They're pretty advanced topics, to say the least.
Absolutely. The final thing that I wanted to mention before we kind of like go through, kind of close off today's discussion is in the book on generic functions, there was a section that I wanted to ask for discussion. 1 second. I got to go find the book. I had one topic that I want to ask. Was it? It was in. So let me see if I can illustrate this a little bit. C2 mop, let me just make sure that this is actually available. Method body available. Method body is not actually available in here. Okay, so what is actually allowed in closure mop for methods? I just want to make sure that when I was looking for a couple of these, I was like trying to figure out, I was trying to map what's described in the book and what's actually in closure mop. So forgive me if some of these questions may not necessarily apply to closure mop, but I was just wondering how the method body for a method works with again, with method combination. I guess this is just for accessing a specific set of expressions directly applied to a specific method instance, but doesn't look like it exists. Okay, never mind about that. This was a question related to something in the MOP implementation in AMOP. So I'll just go through that code to figure that one out. Any other questions from other folks on the introspection utilities?
Just one quick thing back to Elijah again with what we were talking before about redefining the function. Would it be possible? I mean, I don't know if the implementations usually let you do this with the whatever built-in like mop facilities they have, but can you save off the F definition for the initialization that is currently defined and then replace it with your own, and then just call the new function definition that you save that one off as? Or do they not let you usually redefine that stuff?
Say that again.
So, you were saying that you could do something like that, but you'd have to, redefine def class and all that stuff. I'm saying, what if we saved off the f definition for that function to and redefined it as a new function name, like
Oh,
initialized to, and then
hot.
replaced yours. Do
You
like a
mean
hot replace.
hot patching the common Lisp package?
Yeah, basically.
Don't, in short. Yeah, for so many reasons, actually, it's a bad idea. The common Lisp spec says that's explicitly undefined behavior. Anytime you screw around with the common Lisp package, SBCL will yell at you if you try. It has that package locked by default. SBCL will optimize. So part of the problem is that, for one thing, def class is a macro, which means that any code that's already been compiled before your hot patch happens won't respect your hot patch. So, it would only affect some code in the image anyway. That just can cause so many problems, in short.
Okay, noted.
Yeah. Not a good idea.
Undefined behavior basically means
Yeah.
it depends on who you talk to, but it really
Yeah.
means
Any symbols in the CL package have to stay exactly as they are. You can't even add symbols to it. The CL package is explicitly for the symbols that CL defines, and they must exist as they were defined, and nothing can be added, so no additional symbols either. It must be CL, and it must stay CL.
Mhm. Pretty much.
Oh, great.
If an implementation purports to conform to the ANSI spec, then it must have exactly the given set of symbols exported from the common Lisp package, and they must do exactly the things that the spec says they do. And actually, there's pretty much almost nothing else that the spec actually requires of an implementation, but that it defines the common Lisp package. The common Lisp package exports exactly these symbols, and these symbols function in exactly this way. That's actually like pretty much the only thing the spec actually says. Everything else in the spec is some specific, sub detail that can be traced back to one of those main points, that this package must exist, that it must export exactly these symbols, and these symbols have to function exactly this way. Everything else, is some
Which
side
hints
effect.
that implementations aren't even allowed to add symbols to the CL package. That's what the CL user package is for. Implementations are allowed to add their own symbols to the CL user package.
Yeah, no, actually. What they are allowed to do is use additional other implementation-defined packages in the CL user package. I don't think they're strictly allowed to put symbols in there directly. I'm pretty sure the CL user package isn't allowed to have any symbols that it owns. There aren't allowed to be symbols that are homed to the CL user package by the implementation. But implementations are explicitly allowed to use other packages in the CL package, CL user package. But yeah. Yep.
Oh, jeez. So you're basically telling us that just don't bother trying to. If you think you need to add to the CL user package, you're probably doing it wrong.
Well, to the CL package. If you think you want to screw around with the CL package, you've done something wrong. Yes, basically.
Not probably, definitely, yes.
Yeah, because the spec basically. So another thing, right? SBCL has this massive database internally of information about the behavior of the functions in the CL package. And it's properly intense. It's this massive database of details about like what functions are allowed to be optimized around what other functions in exactly these ways. And so if you start, screwing around with the CL package, all of a sudden you can trick the compiler into doing really stupid things. So don't do that. Don't screw with the CL package. It's not a good idea.
Oh, jeez.
Oh yeah, not a good idea.
Good question though.
Yeah.
All right. So if there's nothing else, next week, chapter 3, we're going to actually start being able to extend the language. We're now, at the point where we're going to start hopefully be able to do some crazy stuff with adding a couple of things using the intercessory protocols that are available. If there are any other questions, any other talks, any topics, please post on Discord, post on Mattermost. I'm available on Functional Programming Slack. Folks in the Atlanta area, I'm also available on Tech 404. And new topics, let us know. We will go ahead and address them as they come to us. Thanks for joining us. I'll see you guys next week.
See you then.
Thank you.